right, let's do this free response problem. And we have R is the shaded region bounded by the curves e to the negative x squared, which looks like this one right here, and then 1 minus cosine x, which is this one here. The caveat that we will give you is that this intersection point is not at 1. AP College Board has a habit of giving you a graph that appears one way, but if you actually use the equations, it is entirely something else. It's not entirely something else, but people who missed this question assumed that this intersection point was at x equals 1, and it is not. So the first thing we're going to do is set up area, which is going to be top curve minus bottom curve. So for part A, we are going to have e to the negative x squared minus, and don't forget to put the second curve in parentheses so that that negative sign distributes. And then we need to integrate from 0, which we know starts at 0 because it says first quadrant. And then we need to know this intersection point because that will be our upper limit of integration. So we go to our calculator and we're going to, for y1, type in e to the negative x squared. And I'm going to skip over y2 and y3, which I always leave in there. And for y4, we're going to put in 1 minus cosine of x. And I'm going to go ahead and just do a zoom trig. So I'll do, let's see, second window. Oops, that's not what I wanted. I'm going to do a zoom here. And then I'll do a trig, choice 7. So this should give me what I want in terms of a window. There's my e to the negative x squared, and here comes my 1 minus cosine x. So I'm looking for this intersection point right here. Do the second calc, and I need intersect. I'm going to move my cursor over toward the point of intersection and hit enter 2 more times, and I find out that that x value is actually 0.9419. 0.9419. Now remember that we put y1 as e to the negative x squared and y4 as 1 minus cosine x. So if I go back to my calculator and I go to the home screen, I basically want to integrate, so I'm going to do alpha f2, oops, did not want to do it, there we go, still did not want to do it, alpha, goodness, hold on, alpha f2, and then choice 4 is the integral, and I'm going to integrate from 0 up through 0.9419, and then I'm going to integrate y1 minus y4. So vars y-vars function y1 minus vars y-vars function y4. And of course integrate with respect to x and hit enter. And my answer is going to be 0.590, or you could say 0.591. So you can either round or truncate. Okay, the next problem says, find the volume generated when we rotate R around the x-axis. So that means we need same limits of integration, 0 to 0.9419, and we need big R, which is e to the negative x squared, all squared, minus little r, which is 1 minus cosine x, all squared, big R squared minus little r squared. So we already have y1 entered, and we already have y4 entered as big R and little r. So I can just go back, and by the way, I didn't point out, and I need to point out that I need a pi out in front here, because it's pi r squared for volume. So I'm going to go ahead and type in the pi, first of all, and then I'm going to do the integral, which is alpha f2, choice 4, integrating from 0 to 0.9419. And then I'm going to open parentheses, and I'll do vars y-vars function y1, close parentheses and square it, minus open parentheses vars y-vars function y4, close parentheses, square it, make sure you're integrating with respect to x, and hit enter, and your answer is 1.7466. And you could have said 1.746 or 1.747, either one will work. Okay, last problem on this page is, let's see, we have the region R is the base of a solid, and for each solid, the cross-section perpendicular to the x-axis is a square. So for squares, we need the same limits of integration, but this time we need big R, which is e to the negative x squared, minus little r, and notice that I put parentheses around 1 minus cosine x again, and then square the difference. So I'm going to go back to my calculator, and this time I'm going to do alpha f2 for the integral, choice 4, integrate from 0 to 0.9419. I'm going to open parentheses. I'll have vars, y-vars, function y1, minus vars, y-vars, function y4, close parentheses, and now square that difference. Make sure you are integrating with respect to x, and your answer is going to be 0.461.